All right, let's go ahead and get started. So everybody have a good long weekend? Yeah? Everybody did their programming challenges, right? Looked like everybody did it. So was that okay? Any problems? Or? So today we will just jump right back into linked list, and we will finish linked list today. And then on Friday we will do stacks and queues. So if you remember, last time we met, we were talking about linked list and specifically doubly linked list. The idea being that we have these nodes, they have data in them. In our case, they're just integers. And each node has a pointer either to the next node and to the node before it. And so we came up with a list of functions that we want to implement for this data structure. And these will be in your challenge 1 as well. And so we started setting up our files to create this data structure and to implement these functions. Yes?
So when challenge 1 will be?
I believe challenge 1 will come out next week or the week after that. I'll have to check and see where the other sections are. But it'll be one of those. Yeah.
Do you remember how many challenges we have every semester?
4. Yeah. All right.
And the test will be like asking, how will the test be like? Well, we'll get to that later.
So the test will be over the things that we cover in class. We'll do a review day. I'll give you example questions, a summary of everything. The test will be straightforward.
Multiple choice?
Some of it will be multiple choice, yes. You won't have to write extensive amounts of code or anything. You may have to read some code and say what the output is. But for the most part, it will be multiple choice, and there will probably be some like matching different concepts, just a list of words and a list of definitions. So it's pretty straightforward. I don't think you'll have any real issues with the exam. It's, as long as you look at what we do in class and look at the review, you should be good on the exam. All right, so to make our linked list, we first had to make this node class. So we're going to make 2 classes, a linked list class and a node class. And the node class is just representing each node that we had in the diagram. So we just use an integer for data and then a pointer for next and previous. And then for the linked list class itself, we said that it would have, for the node class itself, we added these constructors. And we used this shorthand. And one of your classmates answered the question for me about why there's no semicolon here. And it is because we were actually kind of defining this, even though we're doing it in the shorthand. The braces are just showing that it is being defined there. C++ thing, not super important, but fun to know. Good to know when you're reading code, and there's lots of C++ code out there. So, the linked list itself. So this class is pretty simple to start with. So we decided to make 2 private fields, the head and the tail, so the start and the end of the list. And those are pointers, just pointers to those nodes. And then we also went ahead and made a constructor with a shorthand that just points those to null, the null pointer to begin with, because we don't have anything in our list. So if you're using an older version of C++, so this was introduced, I think, in C++ 11, and we're far beyond that. But if you are running a different version that's earlier than that, null pointer will not work. You may just need to use kind of all uppercase null, or you can use 0, although people have opinions about that, and it may not be the best thing to do. So that's just a quick note. There are versions of C++ in general that doesn't really affect us, but this is one where it could affect you if you have a version that's older than, I think, C++ 11. So we've got our constructor for the linked list, and we added in a destructor for the linked list. And we'll talk about why we have the destructor and what it does today. And we'll see why we didn't need to do that for the node class necessarily. And so to get started, we want to start by writing our append function so that we can put some data in the list. So let's jump back to our code. And if you remember, I am just working with 3 files here. So I have my test file, which is I've just called testLL.cpp. And that's where I'm just going to use this data structure as we write it and test that it works. I've got my header file for linked list and node. So I've kind of taken a shortcut here since node is such a simple class. I've just included it here right before the linked list class, which you can do. You could also break it into a separate file if you'd like. And then here's that linked list class where we last left it. And so the last thing we had done is we had added the header for the append method here. And then in our linked list class, turn off Copilot. So in our linked list class, we haven't written anything yet in the C++ like in our implementation. We just have the headers. Nothing is written there yet. So just to make sure we are compiling okay, you'll remember this is how we were compiling that, and I'm just doing it in my terminal. Your development environment may do it for you when you hit the play button, but it's this simple. I'm just saying G++ in my case, and then the test, where I have my main function in testLL.cpp, and then my LinkedList.cpp. So I'm just passing both of those in. That'll compile, and by default it goes to a.out, so I can run that, and I get just the print line that I've got in my test file, so I don't have anything else there right now. So let's think about the append function a little bit. So we're going to step through this kind of piece by piece to start with, and as we go, we'll move a little bit quicker. But for append, the first one, I'm just going to step through it, every step that we need to do. So it's kind of good to think about your linked list in kind of the state that it's in. So we're going to add a node to it. We're going to add data, but right now it's completely empty, right? So we've got our head pointer pointing to null, our tail is pointing to null. So it's an empty list. Now, that may not always be the case when we add data, right? So let's say we add some stuff and then later we want to add more, right? So there's already stuff in it in that case. So that's the other case where it's not empty. And in that case, head points to a node and tail points to a node. So these are the 2 conditions we might find the data structure in. So regardless of these 2 conditions, when we added a node to the list, we add data, we're always going to have to create a node for that data. And so I'm just writing this as in a kind of a pseudocode. It's not necessarily C++, but essentially we need to create a node that we're going to add with that data value. So first, let's think of the easier case, and that's when there's nothing in the list at all, right? So we create our new node, and then we know that in this case, there's nothing else in the list. We're the only node. So what do we point to for next? No, yeah. And the same for previous, right? There's nothing else to point to, so we leave those as null, and that's the default. And then as far as the state of our list itself, we had head and tail being null. Since we only have one node in the list, both of them will point to that node at this point. So it is both the head and the tail. It's both the beginning and the end of the list. And so there's a little bit of kind of pseudocode on how you can think about that. So we say that the list head will equal the node that we've added, and the list tail will also point to that node. Okay, so let's look at the non-empty list. This is a little bit more involved. So in this case, we're doing append, which means we're going to add the data to the end of the list. And so in this example, we've got 4 elements in the list, and head points to the first element, tail points to the last, and you can see they're all pointing back and forth to each other like you would expect. And let's say we're adding in this new element, 99. So initially, we create it, and it's just hanging out there. It's not connected to anything. And by default, it points to null, null, null. So what we want to do is we have this that we've created. We have our existing list. We've got to change it so that for our node here, right, first we want next to point to null, because it's going to be at the end of the list. There's nothing after it, right? And that's already the case. It's null by default, so we can leave that. But previous, on our new node, we'll now need to point to what's the current last node in the list. So previous will point to the tail of the list, the current tail. And you can see that illustrated there. This is still pointing to null. So now, on our list itself, we need to do a little bit of work. So currently, tail is still this node, right? Even though this is pointing at that, we don't know about it from over here. So what we're going to do is take our current tail node and its next pointer, which is null, because it's the end of the list right now, needs to point to the new end of the list, this new node. And then we need to take the tail pointer itself and point it at this new node, since it's now the tail of the list. And so there's the first step. So it's hooked in like that. And then the last thing we need to do is change tail. And so at that point, now we've appended an item to the list. And so here's kind of the pseudocode version of that. You can think about it as we've got our node that we're adding. And so we set its previous pointer to be the end of the list. Then we took the current end of the list and we took its next pointer, made it point to our new node. And then we take the current end of the list and have it point to the new node as well.
And
Yes.
the head and tail point to the node themselves and not the next pointer.
Right, yes. Yeah, important to note that, yeah, in all cases they point to the node, each node, rather than anything inside of it. And so you can see this is not too bad. You know, we're just changing where things are pointing, right? But you do have to do this in the right order, right? And you need to keep track of, like if you change one of these and you lose your reference to it, you can get into a world of trouble. So you do have to kind of think about it carefully when you write it out. Make sure that your ordering is right. You'll catch these problems when you test it, but it does get a little bit tricky sometimes if you take quick shortcuts on the code or something, and you forget that you need a reference to something, then you lose that reference by overwriting it. Okay. So this is kind of our overall approach here to appending data to the list. So in the case that we have the empty list, we just set head and tail to our new node. In the case where we have stuff in the list, we do these operations to tack our new node onto the end of the list and update the list to point to it as the tail or the end. In both cases, we had to create the node first. And just to kind of compress this, you can see that's a common step to both of these. So when we write the code, both of them will have this top part, both will have this bottom part, and this will be where the difference is. All right, so let us write the append function. Okay, so we're in our linked list file. I'm going to include linked list, first of all, and then I'm going to start on, just make sure that's visible. Can you guys read that okay? Okay. So let's start with the append function. So you remember we wrote the header for it here, append. So we're just going to, in our implementation over here, we'll do void and then linked list, the scope operator, and then append is what we want, and it takes an integer value, which we'll just call data in this list. And so the first thing I want to do is create a node for the data. So I'm going to do that like this, node. I'm going to call it node to add, and I'm going to make that a new node, and I'm just going to pass the value of the data. So, and this is just creating a little node object. Remember, by default, it has its pointers next and pre set to null. And so this will set the data to data. In a lot of code, you'll see like this name like temp or something, just a quick variable name. I'll usually write it out kind of in more detail just so that if you're looking at this later, it's easier to like read it and know what's going on. But you definitely don't have to write out these longer variable names. Okay, so we've created a node. Now we need to deal with putting it into our linked list structure. So the first condition, if you remember, is if the list is empty. So how to determine if the list is empty? You remember for our linked list we have head and we have tail, which by default are null. And so what we can say is if the head pointer is the null pointer, then the list is empty. So, and this is by, we'll never have an empty list where both head and tail are not null at the same time. So I'm only checking head. I could only check tail if I wanted. And that's just by the way that we'll use the list. They'll never be out of sync. So if the list is completely empty, great, that's the easy case. So what we want to do is we want to set our head to our new node. And this is a pointer to that. If you remember, the star here indicates this is a pointer to a node. So, and my head field is also a pointer to a node. So I'm saying, you know, for this pointer, it's going to be what this is pointing at. So they're both pointing at the same thing now. And then also because it's the only thing in the list, I'll go ahead and make the tail equal to that as well. And that's all we need to do if the list is empty at this point. Now,
the new keyword just makes a new instance of null.
Right. So, yeah, new will allocate the memory and put in the defaults, and then because we call the constructor with data, it'll set the data. And so we'll use new, and new will be paired with another keyword, delete, when we're done here, and that will release all of those resources. So yeah, in this case, that's just us creating that little node, comes with its memory and everything for us. Okay, so now let's go to the little bit more complicated case of if the list is not empty. So, okay. So for this one, what we want to do is we're adding to the end of the list, right? And so the first thing we want to do is take the end of the list, and remember there are elements in the list already, so there are existing things. So our pointer tail points at a node right now, so there's something there. So we'll take tail, and what we want to do is it's now not the end of the list, so it has a next element, which is our new one. So we're going to take tail's next and set it equal to our node to add. And these are all pointers, right? We're all pointing here. So now the tail node's next field points at our new node. After that, we go over to our new node itself, right? And by default, its pointers are pointing both of them to null. You know, its next one is null, and the previous one is null. But since it's at the end of the list, it doesn't have anything next, so null's fine there. But it does have something before it. And so what we'll do is, on our node to add, we'll say that its previous field should point at the current tail of the list. And this is why it's important we do this in order, right? Because the tail is still currently what it was when we came into this. All right. And then we have one last thing to do, and that is to update the tail of the list itself. So we will say that the tail is now equal to the node to add. And that's all we need to do. So that will append a new element to the end of our list. Now, we will compile it. Oh no, what did we do? So here we've got use of undeclared identifier null pointer. So let's see if the namespace is the problem. Ooh, no, we've still got it. Ideas? Nope. Okay. Yeah? No? Okay, so you can see where the error is. Here we go. Okay. So you can see it's in node. Right here is where we're getting that complaint in our LinkedList.h file. Let's see. Yeah, I don't think we have a namespace in this one. So if that makes it any happier. Oh no, that's still not what it wants, right? My version of C++ compiled or changed. Let's see. No. Okay. So let us cheat and see what we're missing here. It's pretty much the same. See, we don't have iostream. I don't really think iostream should do it, but sorry. Oh, interesting. Anybody want to figure that one out later? So for some reason, iostream seems to be implicated here in having null pointer work. And I honestly don't know why, but I'm sure you can find out. Is somehow included with the iostream include, it seems. So I will jump back to my not pre-done ones, and we will continue. All right, so compiles, yay, we're good, but it doesn't do anything yet, right? We can append stuff to it, but in our test code, we haven't done that. We've just made the list. We haven't used it. We haven't done anything. We could use it now, but we don't have a way to see it yet. So let's go ahead and write a function so that we can see what's in the list. Let me jump back to the slides for a second. So we will write the display function. Okay. And so imagine that we have a list with several nodes here, right? And what we're going to do is we're just going to start at the beginning, and we're going to just traverse down the list, printing out the values as we go. Pretty basic. So we'll create a pointer that we'll just call current node. We'll point it at head to start with, and then we'll use a while loop, and we'll just have it change to next until we get to null. And that'll take us down the list. So there's a little bit of pseudocode on that. So you get current node, set it to be the same as the head, then while the current node is not equal null, we print out the data in the current node, and we set the current node to current node next. So let's go ahead and write that. Okay, so we'll jump back to our header file, and that's our pre-done header file. We don't want that. Okay. Here is our working header file. Okay. So we don't have a print or a display method put here in the header yet, so we'll need to add that. And its method or its function signature will just be void display. And so I'm just going to put that displays the list from start to end. And I'm just going to have it, we're going to write it so that it just uses cout, and it's just going to print it from that function. We're not going to return anything or anything like that. So it's just a void method or void function, and it'll do this for us. So let's jump back over to our implementation in LinkedList.cpp, and we'll go ahead and start with void, and then linked list, and we want to do display. I'm going to go ahead and, while I'm thinking about it, include iostream in here because we will be printing things in this one.
These functions shouldn't exist in our header file.
Which functions?
Just like the append and stuff that we wrote here.
Yeah, so by convention, you typically in the header file just write the method or the function signature, just the name, the types, the parameters, and then you do the implementation in a CPP file. You can do it all in the header file. It will work. It's just generally the convention is to split them, which is nice, especially when a project is just a little bit bigger than something basic, because it gets to be a mess, and the header files are a nice, quick kind of they're almost like documentation. You can browse them and see what can this thing do and that kind of thing. But yeah, technically you could put it in the header file if you wanted. Yeah. Okay, so for display, what we're going to do is first just create a temporary pointer to the head of the list. And so I'm going to do it node, because it'll just be pointing to a node. Let me scroll up just a little bit there. And I'm going to just name it current node, just so I know it's currently what we're looking at. And I'm going to set it equal to the current head of the list. So then, there are a few different ways we could do this. What I'm going to do is I'm going to just do this in a while loop. And my condition for the while loop is going to be that current node is not equal to the null pointer. Because if you remember, our nodes at the end, right, next points to null because there's nothing there. And so if we're going down a list, eventually it'll point us to null when there's nothing left. And so that'll end this loop. Okay, so then what we're going to do is just print out the data for this current node that we're in. And I'm going to do that with just a simple cout statement. Again, there are much more beautiful ways to do this, but this will get it done. So if you'll remember, that's just the field called data, and I am using the arrow to access that because this is something that we created using new, and we'll use the arrow functions to do that. All right, and I'm going to just put a space here so that these elements are spaced a bit, and then so that'll print that out. Then the only thing we need to do is move to the next element in the list, right? And so I'll set our current node, and I'll make it equal to what our current node is pointing at as next. And so that'll move us to the next element. And then once this list is done, I am just going to print a new line there for convenience. And that should allow us to display the list that we have. So let's see if it compiles. Oh, good, okay. All right, now we need to actually try it out. So we've got these two functions. We've got append and we've got display. So if you'll remember in our main file, we've got our main method, and I'm just printing out demo start, and then I'm calling a method called test append and display. And up here is where we're going to do that. And so what we're going to do for the linked list is we won't actually create it this way with new. Since we're just going to use it here, we don't have to do that. So we could if we wanted, but it would be more common that you would see list and just, okay. So we have our list, and then let's just do list.display to start with, And so that should print nothing. Let's see if that goes. Oh, we've got a compiler error again. You remember our destructor function, right? So we haven't implemented our destructor. We have to do that because this automatically, when we don't use new here, we let the compiler manage things for us, and it wants to call the destructor on linked list. And we haven't implemented anything there yet. So over in my linked list file, I'm going to go ahead and implement that. Just like that. And so that's where my destructor will go. I'm not going to put anything in there yet. See if that, okay, so that makes the compiler happy with us. Now, we've not done our job, right? We've still got memory where it shouldn't be or whatever. We didn't clean up. It's fine. The process terminated. It took the memory back. We're good. We're going to fix it. But in general, it needs to at least have that destructor that it can call to do it the right way. Okay, so let's run that. Okay, so we got linked list demo start and a blank line. That's good. Let's add some things to our linked list. So I'm going to jump back to the main file, and let's do list.append 12, 14, and 22. And then we'll do list.display. Okay, and we'll compile that and run it. And you get what you'd expect, 12, 14, 22. So we've got a list. We can add things to it. Well, we can add things to the end of it, and we can print it out. And we're not cleaning it up right, so memory is everywhere. But we're on our way. Okay, so let's look at what we need to do next. So we did the append function, and we did the display. Let's go ahead and do prepend. And it's not that different from append. We're just going to add at the beginning of the list rather than the end. So if the list is empty, great. That's exactly what we've done already. Very simple. If the list is not empty, say we've got a list like this. Here's our new element that we want to prepend to the beginning of the list. So I'm going to put it over there. And what we need to do is point its next to the current head of the list. The previous can point to null because it's the beginning of the list. It doesn't have anything before it. And then we need to change the previous of the current head to point to it, and then the head variable itself to point to our new node. So very similar to what we did at the end. We're just doing it at the beginning. And there's our basic code on how we're going to do that. So let's go ahead and just implement that. Okay, so we'll go over to our header file first, and we want to add the prepend function. So it will be a void function, prepend, and it will also just take data. Add to beginning of list. Okay. Then we'll jump back to our C++ file, and let's go ahead and implement that. Void, linked list, prepend, just like that. And we'll do kind of the similar thing that we did with append. First thing we need to do is create a new node, right? So a pointer to a new node, and we'll call it node to add. And I will set that to a new node and pass it the data so that it gets that set. Remember, everything else is null still in there as far as to where it's pointing. So the easy condition first, if our list is empty, and we said we could check that by seeing if head equals to the null pointer. And in that case, we just set tail equal to our node to add and head equal to our node to add. Okay. Otherwise, we've got stuff in the list. So, and we need to put this at the beginning. And so, if you remember, the first thing we need to do is have our current head of the list, so head and we need to change its previous pointer, which since it's first, right now it's pointing at null. There's nothing before it, but now we're going to be before it. So we'll change head's previous pointer to be to the node to add that we just created. Then we need to take the node that we're adding and have its next pointer point to what's currently at the front of the list, because that will be the thing that comes after it. So we'll take node to add, and we'll take its next pointer and have it point to the current head of the list. And then finally, the last thing we need to do is set the head of the list to be our new node that we're prepending, right? Okay, so we've got that. Let's see if it works. Now, I've named this function test append and display, but I'm just going to test prepend in here anyways. So, okay, let's add to the beginning. Okay, so we should be able to do list.prepend, and let's see, we have 12, 14, 22. Let's do like 3, and then 2, and then let's just display it. Okay, let's see if that's compiling for us. Okay, and so you can see it did it in the order that we said first. And we had a list of 12, 14, 22. We said prepend 3, so put the 3 there. Then we called prepend 2, put the 2 there. Then we displayed it, and there's our list. Okay, so we are moving right along here. Let's see what's next. Search. Okay, so this one's pretty easy. This is essentially what we've done already for display, right? So we're looking for a certain data value in this list of nodes, and we're just going to say, like, as soon as we see the first one, because there could be multiple of the same thing in here, right? We're just going to return true if we find it. And if we get all the way down the list and we don't find it, we'll return false. So let's do that. We'll do it the same way we've been doing everything here. First, we'll add the header for that. So it's going to be a Boolean return type, and we're going to search for some data. And we'll say if data is in list, return true. So really basic search. You could think of a lot of other better ways to do this. But this will be helpful. Okay, so let's go ahead and implement it here in our C++ file. The type was a Boolean, bool in C++. And essentially, let's linked list, scope, and search. And we take in one parameter, which is our data. Okay, and so what we're going to do is something very similar to what we've done traversing the list to display it. So we're going to create a temporary pointer in this case. And so I'm just going to call it current node. And I'm going to set it equal to the head of the list. And this will be fine. Also, like, imagine the list is empty, right? So in that case, I'd be setting it to null. It's always good to think about all the different possible conditions that this data structure could be in when we operate on it. Okay. And so what I'm going to do is we're just going to iterate down the list like we did in display, and we did that with the while loop. And so we can say while the current node does not equal null, we'll keep going. And so within this loop, we're going to traverse the list by setting current node equal to current node next. Okay, so that's our incrementing condition. But what we're here to do, if you remember, is we're looking for a data element. So for each node that we look at in this loop, we want to check to see if the data matches the data that we got passed to us. So we'll say if the current node data equals the data that we received in here, then we can just return true, and we're done. Oop, not true. Okay, so if we're coming through here and we find the data and it's a match, we just return true. and we're done with this function. If we keep going and going and going and we don't find it, eventually we'll end up outside of this loop where we can just return false. Okay, let's go test that. So let's do, I'm just going to output so this will return a Boolean value, and I'm just going to print out what it returns. So I'll do list.search, and something we know that's in the list is like 22. And then let's do something we know that's not in the list. Let's see, 13 is not in the list. Okay, so we should find the first one, so we'll get a true, and then we shouldn't find the second one, we should get false, which will be 1 and 0, I believe. Here. Okay, so compile that, and run. Okay, and okay, so you can see that first one that we searched for, we found it, we got a 1, second one, 0. Just like you'd expect, right? Okay, so let's see what else we have left to do here. Okay, here's an important one, remove. So let's say we want to remove an element from the list. And let's just choose this one, for example. What we need to do is we need to rewire these pointers around it, right? Essentially, we need to say, okay, who's in front of you, who's behind you, and we need to link them and remove this guy who's here. And we need to also think about if we're removing the beginning or the end of the list, right? Because then they won't be pointing either back or forward in those conditions. So let's just jump straight to doing that. Okay, so we'll go to our header, and we're going to, let me see if it's, okay, I'm going to return a Boolean. And it'll be a true if we successfully removed something, a false if we didn't find it, similar to our search. And we're doing this just by the data value. And again, this will just be the first instance of the data that we pass. Because if there were multiple, this will just take the first one. And just so like these specific methods and headers are the ones that kind of this course overall uses and the TAs use in the challenge. So that's why I'm writing to these very specific things. There are many ways to do this, right? You know, returning a Boolean, that's one option there of many. Okay, so let's see if we can get through this one. Come over here to our implementation, and we will do bool and linked list, in this case, remove. And we're taking in a data element, we're just removing it by that value that we receive. And so what we need to do first is find the element if it exists, right? And so we've done that in search and display. It's very similar. So I'm going to create a current node, and I'm going to set that equal to head. And then what we're going to do is write our standard loop that while our current node is not null, and to advance that loop, we're going to set current node equal to current node next. Right, we're just traversing down the list. Put that down there. And so now what we need to check is, did we find the data we're trying to remove? That's our first condition, right? So we can say if the current node data equals the data that was passed in, right? So then we've found it. And so we've got to decide what to do in here, which is what we want to remove it. So the way we can break this up many different ways about how we do this. I'm going to do it, I'm going to split it by either it is a node that's in the middle of the list, it has something before it and after it, or it's a node that is at the beginning or end and is in one of those conditions. So I'm just going to write that out, and I'm going to say if the current node is not the head node, and the current node is not the tail node, then we're going to do this specific operation. And what we need to do is take our current node and we need to take what it's pointing at, give that to the one before it, and take what's pointing to it and point it at the one before it as well. So let's do that. So our current node, this is the one we're removing. So what it's pointing at as previous, so the node before it, we want to change what it's pointing at as next, which is the current node, to the node that's after it. So it's a little bit, some steps there, right? So we're going to say, go to the previous node, the one before us, and then set its next node to be what our current next node is. So a little bit of a complex statement there to kind of think through it a piece at a time. Okay. And then we need to do the opposite for pointing in the other direction because we're doubly linked. So we'll say we also need to take our current node and what it's pointing at as next. So the node that's after our current node, whatever it's pointing at as previous, which is the current node right now, needs to be the one that's before us. So that's our previous, right? And so that's just that little rewiring that we saw on the slide, right? We're just picking up that pointer, jumping it over, picking up that pointer, jumping it over. Done. Easy in the middle case. Okay. So now let's deal with the case of it not being in the middle of the list. So I'm going to split it into if it's the head of the list. And so I'm going to say if the current node is the head, then I'm going to set the head equal to the next node. So I'm going to do head next in this case. I could do current. They're the same thing. They're pointing at the same thing. And then I'm going to check that head does not equal null before I do this next thing. And I'm going to set the previous pointer of our new head node to be null, since it's the beginning of the list now. Okay, and so that's what I need to do if it's at the head of the list. Now, if it is at the end of the list, oops, not tally, tail. So we'll say if the current node is the tail, then we will set the tail to the previous node. So we're removing the tail, so we need to have a new tail be the one before it. So that does that. And then again, I'm going to check just to make sure that's not null. And if it's not, I'm going to set its next to be null because there's nothing after it. And then there's one last thing we need to do in this case. So we'll come out after these conditionals. And this is in every case, we need to delete current node, and then we need to return true. And then remember, if we didn't find it, we need to return false out here. All right, and in the last few seconds of class, let us see. If we do list.remove, and let's just remove 3, and then list.display. All right, so 3's gone out of that list. We'll stop there. I will post the full implementation of this on Canvas for you. We'll look at it just a little bit next class, just to go over it and see if you have any questions. Otherwise, we'll do stacks and queues, no quiz or anything like that. So I will see you guys on Friday.